Hello everyone, for this tutorial video I'd like to explain how to compute definite integrals of specific functions using the last formula we derived in the previous video. In particular, if we take this definite integral from point 0 to point 2, we would first take the antiderivative using the formulas we went over previously. Then, evaluate the antiderivative at point 2 and subtract the antiderivative at point 0. And once we do the arithmetic, we should conclude the definite integral is 14/3. The caveat with these types of problems, however, is that the integral must be continuous in the entire domain you are integrating in. There cannot be any breaks. So if we were given a piecewise function like this, we would have to test if it is actually continuous at the point where it splits. And we see from a quick evaluation, unfortunately it is not. It is 6 at one point, and 3 times 1 squared equals 3 at another point. But what you can do is split it into two smaller integrals, where one is on the left-hand part of the break, and one is on the right-hand part of the break. For example, the integral from -2 to 3 does encounter the break along this path, but we can split it up as the integral from -2 to 1 plus the integral from 1 to 3. And once we do the usual processes of computing the integrals using the antiderivative formula, we should conclude that the integral in total is 21. Before we officially discuss how to use the substitution rule for computing definite integrals in the next video, I'd like to explain definite integrals of two specific types of functions, even functions and odd functions. An even function is a function where -1 times x is exactly equal to function of x, and is called an even function because of the symmetry. Similarly, an odd function is function of -x is exactly equal to negative function of x, and is called an odd function because polynomials whose highest power is an odd number will tend to display this behavior, whereas polynomials with an even number as their highest power will display the even function behavior. Because of the convenient definition of an even function, we can see the integral of any even function must logically be the integral from -a to a is 2 times the integral from 0 to a. And likewise, if we know the function we are working with is odd, the integral from -a to a is always exactly equal to 0. Now that I've thoroughly explained how to compute definite integrals using the shorthand formula we found in the previous video, I'd like to talk about how to use the substitution rule for definite integrals in the next video, and how it uses two methods, one from indefinite integrals, and one that is a much quicker method of substituting in terms of u rather than x. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.